based analysis also, where based on the RF received signature, we can try to say, okay, in this particular location, maybe from these 3 base stations, we receive these kind of signals. So this is probably the current location of the UE. Now, given these traditional techniques, we can use the existing infrastructure for 4G, and going forward for 5G, the deployment has already started for the matter. The services are already available. You can actually buy a 5G phone now. But the true 5G, which is millimeter wave based 5G, is not yet available. So I think that deployment also will start in some time. Currently, it is just 5G NR. So once that is there, we can go to higher and higher level of accuracies in terms of classification and localization. This particular work was done by a PhD student in our group, Amala, and Prabhat, who is a master student. He's graduated and now working with Qualcomm, I think. And then Professor Zafar Ali Khan, who is a colleague and collaborator of mine from IIT Hyderabad itself, from the same department. So in this particular work, what we said was, there are so many LTE base stations which are already deployed, eNode Bs which are already deployed, which are continuously transmitting, right? So this signal is omnipresent. If you're in a city, there are so many such transmitters around you. Now, can we use these existing signals to, in some sense, localize an object of interest, right? And there, what we are doing it is we are doing it in a passive sense. So we are not asking the LTE base station to transmit any special signal, because they're already transmitting these broadcast signals, which are essentially these pilot symbols, you can view them as. So with those known pilot symbols or those known broadcast symbols that each base station is transmitting, can we latch on to that information and then use it to A, classify presence or absence of a vehicle, and B, to also localize where the vehicle is parked. So this work was published in ComsNets 2020, where what we did was as follows. So again here, please note, because we are doing it passively, we are going to need certain type of receiver. So the receiver that we used was a USRP. I think it was a USRP B210, if I'm not wrong, where we processed the received signal from the base station, collected the received signal from the base station through this UE, which is essentially a USRP emulating a LTE phone receiver. So this is the broader block diagram, which shows how we applied machine learning in this context. So as in any other traditional machine learning algorithm, there is a testing phase where we try to collect labeled data, use it to test. There is a training phase where we try to collect labeled data, use it to train our machine learning model. And then there is a testing